Now for today's lesson 5-3. Today we're going to basically learn how to use properties of rectangles, rhombuses, and squares to solve problems. So last week we learned specifically about parallelograms. Now there are special types of parallelograms that we need to pay close attention to because they have very, very distinct features of them, and it'll help us to solve problems later on in the unit. So the first special parallelogram that we're going to learn about is a rectangle, which is a quadrilateral with 4 sides. But in comparison to a parallelogram, a rectangle has 4 congruent angles, which are all 90 degrees. Okay. And what you should know is that a rectangle takes on all of the properties of a parallelogram. So we learned 4 properties last week of parallelograms. Parallelograms, the opposite sides are corresponding and congruent. Well, not corresponding, but they are congruent. Opposite angles are congruent. Consecutive angles are supplementary, and diagonals bisect each other. Now, what you need to know here is that, yes, it inherits all of the properties of a parallelogram. However, all 4 angles are 90-degree angles, all right? The second property that you need to know about a rectangle is that the diagonals are congruent. So not only do they bisect each other, but now they are congruent in length. Now, when we get to the proofs, you need to come up with strategies of how you're going to prove a parallelogram is a rectangle or a quadrilateral is a rectangle. And you need to refer back to these 2 distinct features. So in order to prove that all of the angles are going to be 90 degrees, right? You need to use slope. So, right, use slope to prove that lines are perpendicular. Now, what is the purpose of us proving that the line segments here and here are perpendicular? Well, perpendicular lines form right angles. So that's why we need to use slope to prove that the lines are perpendicular, okay? Now for this second distinct feature, it says, you need to prove that the 2 segments or diagonals rather are congruent. Well, how do we prove that? We have to use the distance formula. So use the distance formula to prove that the lines are congruent, all right? The diagonals are congruent. We use the distance formula because we want to see that the 2 diagonals have the same length, okay? And that's the only way that you'll be able to prove that the diagonals are congruent is by using the distance formula. So you see how when we did our unit on coordinate geometry, we now need to use it again for this unit on quadrilaterals and polygons. All right, so now that we know this, let's move on to example 1, right? It says a woodworker constructs a rectangular picture frame so that JK is equal to 50 centimeters and JL is equal to 86 centimeters. Find HM. So what do we know about rectangles? We know that it inherits all of the properties of a parallelogram, okay? We also know with regards to its diagonals here, let's label the diagonals first. So JK, which is the side, is 50 centimeters. And diagonal JL here is 86 centimeters. So and they want us to find HM, which is this little part of the diagonal. So with regards to the diagonals of a rectangle, we know that the diagonals are congruent. So segment KM, which is the first diagonal, is congruent to segment JL. So if JL is 86, right? That means KM must also be 86. And we know that not only are diagonals congruent, right, but they bisect each other. So in order, bisect means cut in half. So in order to find HM, we have to divide this by 2. So 86 divided by 2. So the length of HM is going to be 43 centimeters. And don't forget the dimensions in there. And that's your answer. Okay? Now let's move on. So example 2 is similar to example 1, so you should be able to do that on your own. I want to move on to this other special quadrilateral, which is a rhombus. A rhombus pretty much inherits all of the properties of a parallelogram and a rectangle. All right. So this is what a rhombus looks like. All right. However, it kind of looks like a parallelogram, right? But it's a parallelogram rather with all 4 sides being congruent. All right. So it also takes on all of the properties of a parallelogram. So here's the first one. It inherits all of the properties of a parallelogram. However, all of the sides are going to be congruent. Now, the second one is that the diagonals are perpendicular to each other. So they're not congruent, but they're perpendicular, which means that in the middle here, you're going to have 4 right angles. And you're going to have a total of 4 right triangles, all right? So if these are perpendicular, you have 4 different right triangles here that's joined together at that vertex. The last property is that the diagonals bisect each of the vertices here. So this angle will be congruent to this angle will be congruent to this angle here will be congruent to this angle, and last but not least, this angle will be congruent to this angle. Okay, so it's bisecting each of the vertices. I know that's a lot, but it becomes second nature once you continue to work at it. So let's look at example 3. It says that TVWX is a rhombus. We need to first find TV and find, this should say B, find the measure of angle VTZ. So TV is a side, right? Right here. Well, what do we know about rhombuses? All of the sides are congruent, right? And look at what they gave us. They gave us an expression that represents 2 of the sides. We know that all of the sides are congruent already, and we have 2 expressions. So we can just set these 2 expressions equal to each other, solve for the missing variable. In this case, it's B. And then once we find the value for B, we can just substitute it in to find the length of TV. So that's our strategy. So remember to know the property of a rhombus. All sides are congruent. So once we know that, we're going to set these 2 sides congruent to each other. So XT is going to be congruent to WV, right? And we're going to get, our equation is going to be 3B plus 4 is equal to 13B minus 9. Okay, we're going to do the additive inverse of 3B on both sides. So we get 4 is equal to 10b minus 9. Do the additive inverse of 9. So we get 13 is equal to 10b. So b is equal to 1.3. Now that we have the value for b, we're going to substitute it into any of these expressions here. I'm going to try the easiest one so that you guys have it. So 3b, so xt is equal to 3b plus 4. So 3 times 1.3 plus 4 is equal to 7.9. So segment TV is going to be 7.9. And that's our answer, since all of the sides are congruent. Okay, now let's look at the second part of this question. It wants us to find the measure of angle VTZ. Well, what do we know about this angle here? We know that in a rhombus, the diagonals happen to be perpendicular, which forms 90-degree angles. So what we need to do is we need to find this little angle right here. And it has a little arrow here saying that this is represented by 5a minus 5. So what we need to do is set up an equation, solve for the missing variable a, and then substitute it into here to find this little angle, okay? So my equation will be 14a plus 20 is equal to 90 degrees because this is a 90-degree angle here. That's how I'm gonna solve for a. And I'm gonna do the additive inverse of 20. So you get 14a is equal to 70, and then a is equal to 5. Once you find the missing variable a, you're gonna substitute it in here because you know this one angle here is congruent to this one. This angle, the measure of angle VTZ is going to be 5a minus 5, 5 times 5, which gives us 25, minus 5 is 20. So that angle measure is going to be 20 degrees, and that's our answer. And how do we know this? Because of this property here. Each of the angles, or the vertices in a rhombus, the diagonals are bisecting it. So they're going to be congruent to each other. And that's why we know this, the measure of angle VTZ is going to be 20 degrees. Okay? Example 4 is similar to example 3. So I want you guys to try that one on your own. Okay, it's pretty much the same. All right. Or actually, I can do it with you guys. I'll do it with you guys because you guys may have gotten confused. So let's do it together. All right, so it says CDFG is a rhombus, and it says find CD. Same thing as this one. We know that all the sides are going to be congruent, right? So we have these two sides, which is represented by an expression, right? But because we know that they're congruent, we can just simply set it equal to each other and then solve for a and substitute. So our equation is going to be 5a is equal to 3a plus 17. Do the additive inverse of 3a on both sides. So you get 2a is equal to 17, and a is going to be some decimal. Let's see what that is. It's going to be 8.5. All right. So now that we know that we want to substitute CG, all right, which is represented by 5a. So 5 times 8.5, which gives us 42.5. So the measure, the length of CD is also going to be 42.5. All right, and that's your answer. Now let's look at the second part of this question where it says the measure of GCH, well, find the measure of GCH. So GCH, we need to find this little angle in here. All right, and it says if the measure of GCD is B plus 3, GCD, the whole thing here, is B plus 3 degrees. Oops. And the measure of CDF is 6B minus 40. CDF is 6B minus 40 degrees. Okay, so let's look at this diagram. What do we know about rhombuses? It takes on the same properties of a parallelogram. So these two are going to be supplementary, okay? These two are going to be supplementary, equal to 180. Also, what we need to know is that the diagonals are bisecting the vertices. So this little angle and this little angle will be congruent. So therefore, we will need to divide by 2 in order to get this little angle here. But first, let's solve for the missing variable b. So our equation, I'm just going to write it up here since there's space. Our equation is going to be b plus 3 is equal to 6b minus 40, okay? We're going to do the additive inverse of b on both sides. We're going to get 3 is equal to 5b minus 40. Do the additive inverse of 40 on both sides. So we're going to get 5b is equal to 43. So therefore, b is going to be equal to some decimal 8.6. Wow, we're getting a lot of decimals here. Okay, so now that we know that b is 8.6, let's substitute the value to find the measure of GCD. Why am I only focusing on this one? Because we need to find the smaller angle within this bigger angle here. This angle here is going to be half of this angle. So the measure of angle GCD is represented by b plus 3. And we know that 8.6 plus 3 is going to give us 11.6. So that's going to be 11.6 degrees, actually. All right, so that's the angle measure. And now, in order to find the measure of angle GCH, which is half of this, so we're going to do 11.6 degrees divided by 2. We get 5.8 degrees. So that's your answer. It's going to be 5.8 degrees. Okay. Now let's move on to, guess what? We're moving on to a square. That's another special quadrilateral, which is essentially taking on the properties of a rectangle, a parallelogram, and a rhombus. Can you imagine? So it's taking on all of those properties. So a square has 4 congruent angles, which are all 90 degrees, and all of the sides are now congruent. Well, the question I want to pose to you is, what other quadrilateral has all the sides congruent? Well, we know a rhombus has all of the sides are congruent. But how do we prove that that parallelogram or that quadrilateral is a square and not a rhombus? Well, we know that rhombuses have all 4 sides are congruent, but a square has all 90-degree angles, okay? So that's how you will differentiate between the two. Now, in our geometric proof, right, we're given a coordinate plane with a diagram of a square, right? We need to prove that this square is actually a square, right? This quadrilateral is a square. And how do we do that? By proving that the diagonals are congruent, perpendicular bisectors of each other. Okay, I know that sounds like a lot, but on the Regents, they'll give it to you in steps, so don't worry. But you need to prove that the diagonals are congruent, perpendicular bisectors of each other. So here's a strategy. Well, how do we prove that diagonals are congruent? Well, you use the distance formula. How do we prove that lines are perpendicular? We use slope. How do we determine that segments bisect each other? Well, we can use the midpoint formula here. So, guys, because I'm running out of space, I want to use a separate sheet of paper to do all of this work because I want to make sure it's clear. Okay, so we first need to use this diagram to prove that the diagonals are congruent, the diagonals are perpendicular, and the diagonals bisect each other. All right, and the midpoint proves that because if they bisect each other, they usually pass through the midpoint, the middle of each segment. So they should have the same midpoint. First, let's find the coordinates of the diagonals. So the diagonal is EG. E has the coordinates -4, -1. G has the coordinates 3, 0. So that's the first diagonal. And the second diagonal is FH, which has that coordinate 1, 3, and H is 0, -4. Okay. So now this is diagonal 1 and diagonal 2, number 2. I'm labeling these so that it's just